Hey, what's up guys, welcome back to the channel. In this particular video I will explain one of the standard DSA problems, which is longest common subsequence. This problem is really important guys and frequently asked by many companies, so make sure you stay tuned till the end of the video. Starting with the problem statement, so it says that you are given two strings. You have to find the length of longest subsequence which is present in both of the strings, and both the strings are in uppercase Latin alphabets. So according to the problem, we are given two strings. Both the strings are in uppercase order, and A and B are here representing the length of given strings. So our task is to find the longest common subsequence of these two strings. Okay, so guys, first of all, let me start with what exactly is a subsequence. I am going to write an example in order to explain. So let's say I have a string A, B, C, D, D, E. Guys, a subsequence of a string is basically a set of character that we pick from that particular string while maintaining the order. What does this mean? Let me explain using this example. So from this string, I can pick any set of characters. So it can be a continuous set of character like CDE is one of the possible subsequences. CDE is one of the possible subsequences, or I can pick any discontinuous set of characters. So I can pick A, then C, then E, right? So ACE is again one of the possible subsequences. But if you try to write EAC, then this is not a possible subsequence because you are not following the order, right? So you have to make sure that you follow the order from left to right. This is about subsequence, guys. For any string of length n, you have to, okay, so the total number of subsequences are going to be 2 raised to the power n, right? Now I hope you have got the idea about what exactly is a subsequence. So we can try to write some more subsequence here, like I can have a single character A as the subsequence, or I can have single character B. So single character can be subsequence as well, or I can have any other subsequence like BC, or I can have AD, etc. Right? There are multiple subsequences possible. Now coming back to the problem again, so we have to solve this particular example, right? Let me explain this example. First of all, I'm going to remove the stuff from this particular side. After this, the first task that we are going to do is we are going to write every possible subsequence of the given strings. So let me start with ABC first. What are the subsequences of ABC? So first is a single character A, then we can have AB. After this we can have AC, right? After this we can write a subsequence which are starting from B, so I can have B, then I can have BC, right? After this I can write C as well. So how many are there? 1, 2, 3, 4, 5, 6. Okay, then I can write one subsequence which is ABC, which is the whole string, and then I can write one more subsequence which is an empty string, right? So this way I am able to get all the substrings which are 8 for this particular string, right? Because I am following this particular formula. In order to get the total subsequences for length 3, it is going to be 2 raised to the power 3, which is 8. After this, let me write all the subsequence of this particular string which is BDC. So I have BDC. So for BDC, I can have B, then I can have BD. After this, I can have BC, right? After this, I can have D, then I can have DC, then I can have BDC, which is the whole string, then I can have an empty string. So these are the possible subsequences for BDC. 1, 2, 3, 4, 5, 6, 7. Okay, I'm left with one subsequence, right? What is that? It is going to be a single character C. Now guys, these are the all subsequences of BDC. So what are the common subsequence among all the subsequences? There are multiple common subsequences, like this C is common in both the strings, right? After this, we have BC, which is common in both the strings. Then we have, okay, we have is there any other? We have B, which is common in both the strings, right? So these are the common subsequences. What about the longest common subsequence? So out of all the common subsequences, the subsequence which is longest is going to be our answer. So BC is going to be the answer. What is the length of BC? So length is going to be 2, right? And we have to return the length of longest common subsequence. So the output is going to be 2 for this particular example. Now guys, I hope you have understood the problem well. So let's talk about the solution. Okay, so first we are going to build the intuition. After this, I will talk about the approach. If you guys notice the problem explanation, then the first idea that will come to your mind is quite similar to this one. First, we can simply generate all the subsequences of both the strings. Then we can look for some common subsequences, like this B is a common subsequence, right? After this, we have BC as the common subsequence. Then we have C as the common subsequence. After looking at the common subsequence, we can simply return the one with the maximum length. So 2 is going to be the answer for this particular example, right? Guys, this is the first idea that we have, but there is a problem with this idea. The problem is we are generating all the subsequences for each strings like separately, right? But what we can do is we can generate subsequences for the strings simultaneously. And what is the benefit that we will be getting? See, we are only concerned about the common subsequences, right? After this, we can look for the longest common subsequence. So in order to get the common subsequence, we will consider only those subsequences which are starting from the same character, because only those subsequences are going to be common subsequence, right? Let's say I start like writing subsequences which are starting from character A for this particular string, and I start writing subsequences which are starting from character B for this particular string. So they are not going to be equal. They are never going to be equal. You can see that these three are not going to be equal to any of these three, right? And even it makes sense because the characters are not equal. So when we generate subsequences for both the strings simultaneously, then we can handle the case for equal characters, right? Guys, this is the benefit. So what we can do is we can generate subsequences for these two strings simultaneously. But hold on, till now we don't even know how to generate subsequences for a single string, right? So first of all, let's discuss how we generate subsequences for a single string. Let's say I have a string ABC. So for ABC, I have written all the subsequences, and I have written an interesting observation as well. So see guys, when I say subsequence A, then I'm actually talking about include first character and don't include any other character, right? When I say subsequence AB, then it's include first and second character, then don't include the third character. Similarly, AC basically means that include first and third character and don't include the second character. This is how guys I can generate every possible subsequence of this particular string, right? It's just a game of include or not include. And even you can see here the dry run as well. I'm starting from ABC I equals to 0, right? This is going to start from first character. After this, I have two options, so I can either have A or empty string if I include or don't include. Similarly, I will come to B, and then again I have two options, include or not include, right? I have AB, then A, then B, and then I have simple empty string, right? After this, I come to the last character, right? And this way I'm able to get every possible subsequence of the given string, right? So I just need to traverse to every character, and then I have two options. Okay, so guys, we are going to use a similar idea here. We can start traversing each character, right? So let's say this is pointer I and this is pointer J. Now guys, we have two options. Either these characters are equal, like character at string 1 of I and character at string 2 of J are equal, or if they are not equal, right? Let's handle both the cases. So first of all, I'm going to write if S1 of I is equal to S2 of J. So I'm going to handle this case in this particular block. After this, the second option is going to be considered in else case, right? And of course, we have a function. So we have a function. This function is LCS, right? And this function is going to take I and J. Of course, S1 and S2 are also there, right? So this is the function that we have. And guys, in this function, these are the two conditions. So first of all, let's start with the first condition. It says that if the characters at I and J are equal, right? So see, let me take an example. I have S1 equals to ABC, and then I have S2 equal to A, then D, then B, right? So initially I'm at first character of each like string, right? This is I and this is J, and you can see that these characters are equal. So what I can do is, this means that I can include this particular character in my answer, right? Answer is going to store the longest common subsequence, so I can include this A in my answer. After this, I will look for the longest common subsequence in the remaining string. So what is the remaining string? Remaining string is basically this one, right? And once I have found the longest common subsequence in this particular string, then I can simply append A to the starting and I will get my answer. So if I write longest common subsequence here, then this whole is going to be my longest common subsequence, right? But I'm not concerned about the longest common subsequence itself. I'm concerned about the length, right? So this function is going to have int return type because I want the length. So how I can get the length? See, this is nothing but LCS of I plus 1 and J plus 1. Why I'm saying I plus 1, J plus 1? Because the remaining string is going to be starting from I plus 1 and J plus 1 for this, right? So guys, all I need to do is LCS of I plus 1 and j plus 1. This is how I can get the answer for remaining string, right? Okay guys, s1 and s2 are also there, but I'm writing the pseudocode, so let me save some space here, right? After this guys, whatever answer this particular function call gives me, I'm going to increase that answer by 1 because I have one more character than this particular value, right? So my total answer is 1 plus LCS of this particular remaining strings, right? So this is my answer, or I will say return value. This is my return value because answer is basically storing the subsequence itself. Okay guys, at last I just need to return this, so I'll say that okay, return value. This is about the case when we have equal characters, but what if we don't have equal characters? So let me talk about that case as well guys. So I'm simply going to remove this particular stuff. Okay, so one more case is there where we don't have equal characters. Let's talk about this case. So see here guys, I don't have equal character at I and j for this particular example, right? So when we don't have equal character, then what we can do is we can either match this jth character with any character after I, because it may be possible that this character is equal to any character after this ith character, right? So I'll just move to the next character. So I'll say that okay, j is going to remain same. I'll do I plus 1. It makes sense guys, because you can see that if these characters are not equal, it doesn't mean that this character is not equal to any of these characters. I can compare with this particular string, which is the remaining string, right? I can ignore this a or don't include this a. This is what I was talking about in this particular approach guys. I can include or don't include, right? So I'll not include this a now. I'll simply increase my ith pointer. Or what I can do is I can increase my j. I will say that okay, if this a is not equal to this b, but it is possible that this a is equal to any character after this b, right? So I'll simply do okay, the second option that I have is I comma j plus 1, right? So I have two options here. I have two options. I can either find the longest common subsequence of these two strings, right? So longest common subsequence of these two strings, or I can find the longest common subsequence of let me explain which two strings. So these two strings guys. So these are the two options that I have. Let me write these two options. So I have option 1, which says that LCS of I plus 1 and j, right? And the second option says that LCS of I and j plus 1. See guys, whenever we have equal character, only in that case we are going to include the answer, right? We are increasing by 1. So this means that these two options are always going to give me the common subsequence that we have, right? Common subsequence I'm saying. I'm not saying longest common subsequence. So which one to return? This is the question, which value to return out of these two. Of course I'm concerned about the longest common subsequence, right? You can see here I'm concerned about longest common subsequence. So I will simply return maximum of these two. I hope that makes sense to you guys, because these two are going to give me longest common subsequence of two separate strings, but we have to return the maximum of those two. So I'll simply say that okay, return max of option 1 and option 2. I hope that's clear to you guys. This is how we can solve the problem. But there is one more case we can observe, that this is a recursive function call. You can see that we have the same function here and we are calling the same function, but there is no any base case, right? So we have to write a base case for a recursive function. What could be the base case? See guys, we are increasing either I or j or both, right? We are either increasing I or j or both we are increasing. So this means that there a condition will come where either my I equals to length of string or my j equals to length of string, or both equal, right? So I'll simply write if my I is equal to length of s1 or my j is equal to length of s2. I have to handle this particular case guys. In that case I have to return something, but what to return, this is the question. So what we can return is, let me take an example. Let's say I have a b c and I have a d b here, but my j is currently pointing to this particular position, right, which is the length of the string, which is index at length, or I will say out of bound, right? Or my I is pointing to any index, let's say this one. So guys, in that particular case you can see that there is no any character at j, right? So this means that the common subsequence is going to be for these two string, the common subsequence basically going to be of length 0, right? So this is what we need to run for this case, right? Or we can have the same case again, but in reverse order, like we can have a b c and then a d b, and now I is pointing to the length and j is pointing to somewhere at the string character, right? So in this case again we are going to return 0 because we don't have any character in this particular string, right? Or we can not have any longest common subsequence in these two strings because I don't have any string here. So guys, this is how we can write the recursive implementation for the solution. You can see that this is going to recursively find out which is the longest common subsequence and what is the time complexity. So in the worst case, you can again see that if this condition is not true for any case, then I will have two options, right? For any function call, I will have two options, then again two options, then again two options. So this is similar to the previous one. So the time complexity is going to be O of 2 raised to the power n, right? Here n is basically representing the maximum of length of this string and length of this string. So these are basically represented by a and b. You can see here a and b are representing the length, right? So maximum of a and b is equal to n. I hope guys now the recursive approach is clear to you. So let's talk about what optimizations we can do in this particular approach. Before we talk about optimization, let's try to understand the problem with the current approach that we have. So I have written one example here, and see guys, for this particular example, initially I and j are equal to 0, so I'm going to call this particular function, right? I equals to 0, j equals to 0. After this, if you see the character at I and j, so a and e are there which are not equal, right? Whenever we don't have equal character, so we always make two function call. First is for I plus 1 and j, and then second is for I and j plus 1. Then we return maximum of these two calls, right? So these are the two calls that we have. Again, for I plus 1 and j, you can see that I have b and e, right? So these are again not equal, so again two calls we have. And for this particular case, again you can see that I have a and then I have f, right? These two are again not equal, so again I have two calls. And now I want you to notice something here, guys. See, what is this sub problem? This subproblem says that I equals to 1 and j equals to 1. So I have to find the LCS of I equals to 1, j equals to 1. This means that I have to find the LCS of these two strings, right? These two strings I have to find the LCS of. And what about this one? This subproblem says the same thing. It says that find the LCS starting from I equals to 1 and j equals to 1. So guys, you can see that we have same subproblems again and again, right? We are solving first this subproblem, then when we come to this particular case, then we again solve this particular subproblem, right? This is something that we have to avoid, guys. We have to avoid this thing. Why? Because this is going to increase the work that we are doing. So how we can avoid this? We can simply store this subproblem somewhere in a data structure. Then before we solve this, we have to check whether we have already solved it or not, right? So guys, this particular concept where we have like repeated subproblem, we call this overlapping subproblems, right? And one more thing that we can observe here is we have some like optimal substructure, like solution to any problem basically depends on solution to subproblems, right? These are nothing but subproblems, and even this is a subproblem again. So guys, solution to every problem depends on solution to subproblem. So there are two things that we have observed. These are the two conditions, and whenever we have these two conditions, then we say that the problem is basically a DP problem or a dynamic programming problem, right? So this problem is a problem which is based on DP on strings, right? And whenever we have a DP problem, so there are two ways to solve that particular problem. The first one is memoization and the second one is tabulation. I am going to start from memoization. You can see that guys, we have the dry run here, right? And in memoization, what we do is we store every subproblem in a data structure. So each subproblem is basically represented by I and j, right? We have some value of I and j here, even you can see here. So we need a data structure which is going to represent every subproblem uniquely. So we can have a 2D array. Let's name it DP because DP makes more sense here. This is a dynamic programming problem, right? So guys, this DP array is going to be a 2D array, and whenever we have DP of I and j, so this is basically going to represent a subproblem for I and j, and you can see that we have unique values of I and j each time, right? So guys, this is how we can store every subproblem in a data structure. Then when we solve a subproblem, we first look at whether we have already solved it, and then only we solve it, right? How we can write the code for this, guys? So see, we have a DP array. We are going to initialize this array with -1, right? And after this, we are going to override the values. You can see that we are going to store the subproblems. How we can store? I can simply write DP of ij equals to this particular value before we return this value, right? This is how we can store the subproblems, DP of ij. And guys, whenever we have stored the subproblem, then one thing is sure, that value -1 will not be there anymore, right? So we can check. At this point, we will check if my dp of dp of ij is not equal to -1, in that case we can say that problem is already solved, right? So we just need to return that particular solution because we are not going to solve the same problem again. So simply return dp of I and j. This is about the memoization approach, guys. And what is the time complexity? So see, we are never going to have more than uh, n cross m, or the size of matrix. We are not going to have more than these sub problems, right? So the time complexity is the size of this particular dp array. What is the size of dp array? So dp of ij is basically representing the solution, right? So maximum value of I and j are going to decide the size. What is the maximum value of I that I can have? It depends on the value of on the length of s1, right? So what is the length of s1 that we can have? According to the problem, it's represented by a. So I'll say that okay, dp of a plus 1 is the maximum size of I, right? Because we have this condition as well. And what is the maximum value of j? So maximum value of j depends on size of s2, so it's represented by b. So I'll write b plus 1, right? This is how, guys, I can write the size of dp array. And now the number of subproblem is not going to be more than size of this, so time complexity will be similar to O of a cross b, and space complexity will be again O of a cross b, because we are using some extra space, right? And apart from this, we are also using some extra recursion stack space, so this is again a cross b, right? So guys, this is about the time complexity and space complexity. What about the code? Let me show you the code, guys. So this is the code that we have. You can see that, guys, we have a solve function, right? And this solve function is quite similar to the recursive approach. The only difference is we are doing some modification here. We are checking here whether we have already solved the problem, right? And we are doing the same stuff here as well. And this is the Python code, guys, and this is the Java code that we have. Now I hope you have understood the memoization approach. The only problem with the memoization approach is the extra recursion space that we are using, right? And there are some time complexity problems as well, like you can see that we are calling the same function again. Of course, we are handling the case as well, but still we are calling the function, right? We are at least calling the function. So the time complexity is bit more than O of a cross b, because the processor or the system or the CPU is doing some extra work here. That's why the Python code is going to give you the time limit exceed error, guys. And in the tabulation approach, we are going to talk about how we can handle like how we can write a code which is something independent of this recursive call, right? Because only in that way we are going to handle this particular extra recursion stack space. So guys, let's talk about the recursive okay, my bad, let's talk about the tabulation approach now. Let me change the page first. Guys, I have written the recursive relation here, and we are going to use this particular recursive relation in order to figure out the tabulation approach, right? So guys, tabulation approach is basically also known as bottom-up dynamic programming, right? And why we say bottom-up dynamic programming? So bottom-up basically means that unlike we do in recursive approach, where we start from I equals to 0, then we move towards the base case, right? What we do in bottom up is we start from the base case itself, and then we move towards the solution to greater subproblem. What does this mean? So let me explain, guys. If I have A, B, C and B, C, D as the example, so in normal dynamic programming, or this is known as top-down approach. So guys, I'll write top-down here. This is an ordinary recursive approach where we can apply memoization. So that particular memoization will be known as top-down dynamic programming. So what we do is we start from I equals to 0. This is representing the solution to this particular subproblem, right? This is the main problem, and then we move towards the subproblem, and at last we simply go to the base case, right? But what we do in bottom up is we start from the base case itself, and then we start building the solution for greater subproblem, and at last we have the solution for the main subproblem that we have, right? So we are going to start from the base case. What is the base case? I equals to A or J equals to B, right? So I'm going to start from this particular place. This is my base case, right? After this, I'll start filling all the values here, and then I will move towards the main problem that we have, which is present here, right? For I equals to 0 and j equals to 0, this is the main problem that we have. So let me start a loop, guys. This is the matrix, right? So I'm going to iterate over this particular 2D array. So for I equals to A, then I is greater than equal to 0, then I minus minus, right? This is the first loop that we have. After this, we need the second loop. So again, j equals to b. So for j equals to b, then j is greater than equal to 0, then j minus minus, right? Inside this, guys, I'm going to have every particular cell of this DP array, and for every cell I'm going to represent every subproblem as DP of ij, right? DP of ij is basically going to represent every subproblem. So I will first check the base case. If my I is equal to A or my j is equal to B, in that case I'll say that DP of ij, which is the current subproblem, is going to be 0, right? This is what the answer of base case. After this I have second subproblem, so I'll say that okay, if my s1 of I is equal to s2 of j, in that case dp of ij will be equal to 1 plus, what is this, guys? I can represent this as dp of I plus 1 and j plus 1, because I know this is basically a solution to a subproblem, and for this DP array the solution to subproblem is present in this particular index, right? After this we have this particular case, so I'll write else my DP of I and j is going to be max of DP of I plus 1 and j, and then a dp of, okay, I got very less space here, so I hope you understand this, guys. Dp of I and j plus 1, right? This is what it means, and I have to write else if here, because you can see that if this condition is true, then I have to if this condition is not true, only then I will come to this particular condition, right? This is, guys, about the DP approach that we have, or tabulation approach. At last I just need to return DP of 0, 0, because this is what the main sub problem is for I equals to 0 and j equals to 0. This is all about the tabulation approach, guys. The time complexity is again O of A cross B, and you can see that this code is something independent of the recursive code that we have here, guys. Now I hope you have understood the tabulation approach as well. Let me show you the code, guys. So I have written the code here. You can see that, guys. First I'm making the DP array, then I'm simply filling out the values in the DP array, right? I start from the base case, then we move towards the main problem that we have. So again, this is the code in Python language, and this is the code in Java language, guys. Now I hope you have understood everything related to this problem, like the recursive approach, then we have memoization approach, then the tabulation approach. So this is all about this video. Thank you.